Okay, this is Joe Kaiser with StackIQ. We're going to get started now. If you're having any difficulty seeing my screen, please let me know in the chat. What we're going to do today is we're going to go through a brief demonstration, a quick demonstration of Stacki and what it does. And then we're going to pile on top of that. We're going to do the HDP bridge roll, which it consists of the software required to get an Embari appliance up and functioning so that you can use that Embari appliance to gather in the rest of the cluster nodes to be a Hadoop installation. I'm happy to take questions during the program if we have downtime in between parts of the demo. Otherwise, I'll take them at the end. So just please go ahead and put them into the chat. This is being recorded for posterity. Okay, so I am the Director of Open Source Engineering. My name is Joe Kaiser. They finally gave me a title about a month ago. And as being the director of that, it's in my purview to produce pallets and configuration and carts that meet the end user requirements of people who are using Stacki, and to do so in a purely open source way so that there is no constraint upon on you for licensing or anything else. So these are pallets and things that we will be releasing for you to consume. For those of you who have never heard of Stacki, what Stacki is a fast provisioning tool for bare metal. It does virtual machines as well. We don't care as long as a system presents with a PXE request and a disk on it. We have a number of things that are in Stacki that make it extremely fast and very robust. We are based on CentOS Red Hat, and we do Kickstart. We do not do image generation. Just before we keep going, if you are interested at all in this during the time, go ahead and take a look at the source code for Stacki and download it. We have a Slack channel and Google groups where we're more than happy to answer your questions. And there's also a Vagrant stack to go ahead and kick the tires. So some of the things that it installs on bare metal. I mean, that's really our main focus. It's Kickstart based. It's not image based. There's parallel formatting of things so that the difference between installing 10 nodes and several hundred nodes is minimal in terms of the time. There's parallel formatting of disk, which no other installer does. And that includes Cobbler, Satellite, Juju, all that kind of thing. They don't do that. Parallel sharing of RPMs as well. So that happens during the installation. We do a peer-to-peer network so that getting the RPMs onto the machines is shared among all the machines. And so the period of time that it takes to do that is the time it takes to get those RPMs to one machine. This way it takes the load off the front end and it makes it extremely fast. We're CentOS RHEL based. We do have Ubuntu and SLES, but those are in the Pro version. For networking, we can do multiple subnets, VLANing, bonding. We can serve PXE to them, not serve PXE to them, do DNS for the local part, and use your regular site DNS for name resolution within your subnet. It's all up to you. Storage, we also do controller configuration and partitioning of disk. So controller configuration, you'll note, especially with Hadoop, but this is a big problem, the configuration of a bunch of machines that have a significant amount of disk, when you have to tear that disk apart, is significant. It usually takes 60 to 80 keystrokes to change a RAID configuration on one of those machines. You can import the controller configuration for those machines. It will break apart the storage controller configuration and put it together in the way that you want. So RAIDed system disks, JBeta everywhere else. Hot swap, RAID 1, RAID 6. You can put all that into a spreadsheet and you can dictate how that's going to be, and you'll never touch a keyboard and monitor to do that again. We also do partitioning that you can dump in there. We'll do a partitioning file today that's pretty basic for the set of machines that I have. And you can set that up on a global level, a per host level, or an appliance level. And we'll see that at the appliance level today. Basically, what Stacki is, it enables you to manage a set of machines in the same way that you would manage one. It gives you an SSH passwordless access to the backend nodes with a clustered command line to run commands there, to set configuration data, all that kind of thing that you would do normally in Linux, you can do here. So what we're debuting today is the Hortonworks Stacki HTTP Bridge pallet. And we'll go through this as part of the demo so that you can see how it actually functions. What it does is it provides the software required to be able to get a set of machines up and prepped for Hadoop, and then creates an Mbari appliance from which you will deploy a Hadoop onto the rest of the cluster. We do not do automatic configuration of Mbari. We had done that in some previous proprietary pallets, and we did not want to do that here. For those of you who may want to take this pallet and run with it, that's certainly an area in which that you could certainly contribute to this project or to fork it yourself. We have some ideas on how to go about doing that, and more than happy to contribute to what you're thinking there. So we're going to have to download a bunch of software as well. We're not going to do that during this demo because otherwise it'll make it too long. But we'll show you how to go about that if you are on a completely closed network or on a actually have one of the machines, typically the front end, open to the internet. So before I start with the demo, I'll say thanks. Okay, so again, any questions, go ahead and put in the chat. So what we're going to do is I'm going to do this like it's a cooking demonstration. I will put in, we'll start up front-end installation, get it going to show you how to do a front end, and then we'll go ahead to a cluster that already has the software that we need and install that software, and then go ahead and get us to the point where we're going through the Mbari installation. So to demonstrate a front-end install, there are two ways to do it, and this is one of the ways that we typically do it, and I'll talk briefly about the other way you can do it. So I have a VirtualBox instance here. We've got a system. The front end needs to be optical and hard disk. It's the only one that is not Pixie first. Storage, I'm going to install the Stacki 3.2 version with for CentOS 7. The Stacki OS ISO, which is downloadable off of the website or from the GitHub repository, consists of the Stacki software and a minimal CentOS 7 OS. So it's the bare minimum set of packages to get a front end working and to get back-end nodes up to a ping and a prompt. We're going to want to supplement that for Hadoop, and you'll want to supplement that for other applications, and I'll show you how to do that in a bit. Turning off the audio, network. I actually have, so typically our Stacki 3.2 on up assumes that you're only going to have one interface. That will be the very first interface it discovers, and it will be on the network that will be communicating with the backend node. So it's it's the network on which it will answer Pixie requests from the backend machines. This might be a site network, in which case you only have one. You might want this as just a pure management network, and it's totally private to anything except the front end and the back end nodes, and that's fine. You can always add a second interface, a third interface. You can plug multiple networks in, but the very first time you install a front end, it's the only interface that gets done. On this particular VirtualBox, when I do testing, I always like to get out to the internet, so I typically plumb both of the interfaces that are on this laptop to the internet. Ports, I don't use serial. Okay, so we're going to get going here, and let's start this up. So when you get to the first screen, it's going to request whether you install via DVD or USB. If you put the Stacki OS on USB, you can now boot it from USB. We are well aware of the fact that lots of people don't have an external DVD kicking around, let alone internal DVDs on their machines. So this is going to bring us to a typical installation screen that you would see on almost any Red Hat server. And we'll answer some questions from there, and then it should get the front end up and running. The other way to do the install of the front end or the management server is to build a bare minimum CentOS 7 install, grab the ISOs from that install, and then using that and a script from the Stacki OS ISO, which you would pull out of it, you can add it to an already running CentOS vanilla installation. We're not going to cover that here. It's covered in our documentation. And so I'm in Mountain Time, so we're going to choose America Denver for our time zone. We're going to give this a Stacki test jcloud.com. jcloud is the internal subnet for the lab here. We're going to do this on the first interface. And we'll give it an address. We'll make it a very large subnet, and we're going to route it only to itself. Okay, choose a password. This should be typical if you've ever installed a CentOS front or Red Hat front end. This is typical. Choose a better password than that. Okay, and partitioning. So let's talk about partitioning for a bit. If you choose automated here, we have made a default set of decisions for you with regard to how this is going to be partitioned. We partition on the first boot disk a slash of 16 gig, a var of 20 gig, a minimum amount of swap, I believe it's 4096, and the rest of it is done. The rest of the drive is done as slash export or slash state partition 1. Slash export is where all the software sits, and so you want to make that relatively large. If you choose to go manual, you'll be presented with a regular, well, hey, we could actually do that. Before we get to the partitioning, we'll select these two palettes, the OS and Stacki. They're required. You have to have them. And then we'll click continue and install. And now we should be brought to a partitioning screen. And this partitioning screen allows you to put on the partitioning that you require. That partitioning can be exactly as you want it. So if you're doing LVM, if you got multiple disks, you want to do all the disks, then go ahead and do that. So here you would go ahead and do the partitioning that you want. As long as you have a slash, a var, and an export, we can do that. So I wonder if it'll let me choose that. No. So from here, I would have chosen the automatic partitioning earlier, and then this would have just installed. It would have brought to the installation, would have brought us to a ping and a prompt, and we're just going to power this off, and we're going to go to an already running machine. Okay, so this is my current machine. If this is not large enough, somebody please give me a shout out here. Or text me or something. All right, so what I currently have here is I have no machines, stack list host. Actually, hey, I do have machines. Let's remove them. Okay, I have no machines. So when you first get an installation, what you have is just the front end listed as a machine. And in terms of palettes, what you have is you have the OS palette and the Stacki palette. Now let me explain what you're seeing at the moment. What you're seeing at the moment is the fact that I've added a CentOS palette and a CentOS updates. As I said before, the OS palette that we provide is a minimal CentOS distribution, and it gets your front end up and going. It may not be sufficient for your needs. And if it's not, then what you want to do is you want to grab the ISOs off the web from CentOS or CentOS updates from CentOS. So we also have CentOS updates. Those are all available, and I'll link them on the GitHub page in case that you need them, just so that they're in an easy place to get. So what I've done is I've added these as pallets, and I've set them to enabled for the default, and I've disabled the OS one because the OS one and the CentOS one would conflict, and we don't want to have that. So I have pallets, I have CentOS pallets, and now what I need is I need the software for the Stacki HDP. So I've downloaded the Stacki HDP bridge from the web. This is linked into from the documentation on GitHub, and we're going to add a pallet, and this is a pallet, and this is how you add it. A pallet, make it so you can see that better. A pallet is an ISO file that has RPMs, packaging, and sometimes configuration wrapped in it. So like the CentOS ISOs that you pull from the web, if you add them as a pallet, they're only RPMs, and you don't have to do anything to configure them from there. With the Stacki HDP bridge, we're going to add it. Pallets are not enabled by default, so we're going to enable it. So now it's enabled. So now this pallet will run in our default box, and a box is a way of putting things together and assigning machines to a particular box. Default is what comes up first. You can create your own boxes, and you can put your own different ISOs or pallets in them. The Stacki HDP bridge, however, does require some running. So there's a command called stack run pallet. And if there's any configuration information that has to be run on the front end, it's kickstart transformed into shell, it will run. So we're going to take a look to see what's going to happen here if we run this. So you can see it's been converted into a bash shell from XML. Yum install, we're going to get a RPM, a JDK, and a foundation PY request, which is required to be created. It's going to create an export HTTP, httpd.cfg, which creates the particular version we're going to be using for HTTP. And then everything else is saving config files. So now we're going to go ahead and run this for real. Pipe it to bash. And it'll do its yum install, and then it'll configure its scripts. So I'm essentially just if you look at the GitHub documentation for the Stacki HDP bridge roll, I'm essentially just doing all the instructions that are there. And if you find any instructions that are incorrect, let me know. Okay, so per the instructions, we create an HTTP directory that allows us to get all the HTTP configuration. Let's make sure I can get out here. So the thing with this is that it requires that the front, in order to be able to run the get HTTP script, which will download Mbari 242.0, HTTP 2.5.30, it has to have outside access. And the way we get this, assuming that you have it, is you run the get HTTP. And what's this going to do is going to pull the repo information from HTTP and Mbari. And then when it's going to do, it's going to mirror those repositories and put all the software into a particular, ISOs. And then this script will load those ISOs automatically. I don't want to do that here because this can take a lot of time. So we're going to quit this. And we're actually just going to go get the ISOs that have been downloaded previously. So what happened was when we ran the get HTTP script, we got HTTP, HTTP utils, and updates in Mbari, all of which are required and have packages in order to be able to install machines. So we're going to add those as pallets. And this can take a bit of time because you have to unpeel the pallet and copy all the RPMs and all that sort of thing. So this might take a minute. So while that's happening, I'll answer a couple of questions. Okay, so there's a question from Sohail. Is there any Cloudera palette? There's not currently a Cloudera palette, but the fact that I am the director of open source engineering means that I am more than happy to take requests and desires from the community and work on is certainly the first revision of a palette and hand it over. Continue to help with whatever needs to be done. We have done a Cloudera palette in the past. It's about as easy as this one is as well. So if somebody would like coaching for that, I'm happy to do it. You do not have to wait for the latest version. You can actually use Stacki and install Cloudera on your own. You don't have to wait for us to do a palette. It's not really a problem because pretty much what you do is you install a bunch of backend nodes. They're up at a ping and a prompt, and then you go follow the instructions for installation for Cloudera. Part of the reason why we started doing this, why we started to put pallets together, is that, and really to emphasize using Stacki as your provisioning tool, is that every instruction set from Cloudera, Hortonworks, MapR, OpenStack, Kubernetes, all of that, Docker, they all assume that their instructions start at step one, which is first install a cluster. Well, if you don't have a cluster installed, how do you go about doing that? And many of them don't have tools or don't have a set of tools that allow you to get the kind of consistency you need when you're deploying their applications. So to us, Cloudera, Hortonworks, Kubernetes, it's just an app. To us, it's just an application because that's the stuff that goes on top of real electrons on real silicon. So, okay, I'm off my rant. So I'll get to the next set of questions as we start to do some installation here. So stack list palette. So you can see, let me give you a better view of this. So we have our HTTP2 tills and updates in Bari. They are enabled. I didn't do that intentionally, so let's make sure. May have been because I ran the get HTTP script. Okay. So what this does is this creates a repository file on the Stacki repo that consists of all of the repos that we have enabled in a particular box. This makes the front end the Yum repository for this set of machines. We like that because then all those RPM during the installations go through the Stacki tracker, the Avalanche installer, which then shares all those RPMs. And it means that when you decide that you need to add something to the backend node, say LSOF isn't on the machines, and you want that package, you can do a stack run host command yum-y install LSOF, and it'll be put on there. So because it goes back to the front end and looks for it. So backends are pointed to the front end as their Yum repository. So we said what we don't have machines, so we're going to add some machines. So there are two ways to do this. I'm going to show you the way if you have the opportunity to, if you have control over your network. If you can have control over your network, you can run a program called insert ethers. This makes the DHCP server on the front end promiscuous. It will answer any DHCP request, which is fine if you have control of your network. It's not fine if your networking team says, no, you can't do that. But let's say you do. And that's the case, then you would select your appliance type. You would install one Embari appliance, boot up the machine. It would make the Pixie request. It would start to install as an Embari appliance. You quit out of that. And now, after that Embari appliance has started installing, you can do all the back-end ones. Push the buttons or power them on with IPMI tool or wake on LAN, and they will start to come in. They'll report themselves automatically with an assigned IP and a MAC address and a default host name. So you can do discovery like that. Many people cannot. And if you can't, then what you need to supply is a spreadsheet. So this spreadsheet or a kick sheet allows you to define the host that you need in order to be able to install. And that way, when the DHCP server runs, it will only answer for these machines on this subnet. So and you only have to put the interface that is going to be it's going to be installing over. So usually that's whatever the network the front end sits on and is going to answer DHCP. So in this particular machine, in this particular file, you need to put the host names, what kind of appliance it is. If this is the default interface, which is true, and it's a back-end appliance, and rack and rank says where it is in the rack. Give it its IP, its MAC address, the interface, and the network that it's on. I highly recommend, if you do bonding, if you want to do bonding, I highly recommend installing all your machines once as plain vanilla in order to be able to flesh out any hardware or networking issues, and then go about layering on complexity on top of that. So what we're going to do is we're going to add this file. Well, we have no host. And we actually want to make backend 00. We want to change that its appliance. So we have a number of appliances here. So we have backend. When I did the stack run palette of the Stacki HDP bridge roll, it created an Embari appliance for us. And we want to use this at this time, so we can get one Embari appliance and all the rest backend nodes. Okay, so we changed that. Okay, so you see we have a stackless host. We have one Embari appliance and 4 backend nodes. When you set up machines in this way with a host file, when they boot, they are going to boot from localhost. This is a flag. The host boot flag sets to OS, which means it boots from OS. Or we can set it to install, which means the next time it comes up, it will install. By default, when you add machines, it's set to OS because you may not be ready to install all that backend machines, but we are, so we're going to. So we're going to set that action. And we're going to set it for both the backend appliances and Embari appliance. So this will apply to any appliance listed, any machine listed as a backend or an Embari. And we're going to set this to install. If you're familiar with Linux, what this does is it changes this configuration for you. It automatically puts the TFTP correct kickstart configuration in order to do the installation. You don't have to know that, but if you're wondering what it does, that's what it does. And during install, this boot action is going to be turned back to OS. So after the successful installation, it will not try and reinstall itself. Okay, there are a couple other things that we want to do here. So in particular, can I do that? Okay. So in particular, you get the default partitioning on these machines, and we may not want that. So we're going to create a partition CSV that's going to get applied to nodes based upon their appliance type. So the back end is going to get a Hadoop 01. So this particular set of machines only has 2 disks. It's got a system disk and it's got 1 data disk. So they're woefully underpowered for this demonstration, but it's enough to give you an idea of what's going on. Mbari also, we're going to not bother to do the second disk on that one. We could. It's probably not a big deal one way or the other. But again, you can decide what your partitioning scheme is by giving the disk, the partition, the size, and the file system type. So we're going to load those. And you can see we've got slightly different things for each of these. Okay, there's also storage controller configuration. These machines do not respond to and don't have enough disks to warrant a controller configuration. But a controller configuration can set up system disks, whichever the 2 disks are, as mirrored arrays, and then everything else is JBOD. And that's typically what we see. Sometimes we'll get people doing 4 disks that are mirrored and striped with a host array, but they have with a global hot spare for that. But those people have a lot of money. So, okay, so one other thing we need to do here, we need to set an attribute. Attributes are key value pairs that are held in the database that you can use to fire or not fire configuration in the kickstart. Particularly the value nuke disks does a thing in particular with partitioning. And we want to set this when we have new hosts because we want to redo all of the disk drive partitioning and formatting for our machines. So we're going to set this, and then we're going to start the machines, and then I'm going to go into a little more depth on what that's about. So let's get some machines going. So in the lab we have in the lab, which you're now hearing the launching of, in the lab we have Serial Console, IPMI tool going through the BMC because I'm too cheap to pay for the Dell licensing. And all of that's multiplexed with Con Server on a Raspberry Pi, which acts as my DMZ. So what we should be seeing here is we're going to be seeing the installation via Serial Console. And hopefully I'm not too loud. So or it's not too loud. They should chill out in a minute here. So we got backend 4. So when they come up, backend 00 should be, if I did this right, and your mama said never do live demos. Backend 00 should be our Mbari appliance, and the 1 through 4 should be just Hadoop nodes. So one way to see what's going to run on your back-end machines is to list the host profile. This essentially is the kickstart that gets generated when it makes the request. If you get no errors during this, it's good. You can see that we're going to get Mbari on here and a base and a client. And awesome. That's a good-looking kickstart there. Okay, so let me go back to nuke disks. So nuke disks, the only way you lose data on machines that you've installed prior with Stacki is if you throw nuke disks or nuke controller. If you want to reset the controllers, we have a way to nuke the controller configuration and set up a new disk configuration. Nuke disks reformats and repartitions a set of disks. If you do not throw nuke disks and you reinstall a set of machines, the only things that get reformatted are / var, and temp. So you never lose data unless you want to, which is extremely critical, and it came about because of one of our large clients who was doing Hadoop, and there were lots of iterations on their configuration, so sometimes it was easier to install a set of machines. But they already had data in there, and we did not want to lose the data on those disks for Hadoop. You can leave all that data alone because a reinstall will only repartition all disks if you throw new disks. That being said, you can also define your own Kickstart configuration. You can our key values and attributes. So we have a way to customize, and we customize with carts. This particular set of machines has a customization because there are some things when I install that irritate me. I've been dealing with with Kubernetes over the last few weeks, and I wanted to streamline some of those things. So what happens is I get wireless RPMs. These machines aren't wireless. IVTV, I don't need that. So in my package tags, I'm going to add them. Say I wanted LSOF on here. I could add it as a package tag. And when I run the machines on Kickstart and install them, this will be installed. Post tags are the same way. These tags map to Kickstart headings. Kickstart has a package section. It has a post section. It has a pre section. These tags are just HTML tags that map to it. Let's see. So we've got some XFS stuff happening. We've got partitioning happening. Partitioning happens in parallel, even though on serially you can't see that, but it happens all at the same time. So the difference between formatting 24 disks and 1 disk is the cost of formatting 1 disk. Okay, so post tags, let's say that we have a key value pair. We'll call it Bob. Its value is going to be true. Why am I not spelling that right? That's why. Okay, so we have this adder called Bob. And its value weights to true. So let's say we wanted to do something only if this evaluates to true. So every attribute can be added as an XML entity, and then we can do something if this condition is true. So box. So if you look at the boxes, that cart, we assign carts and pallets to it. Site customization goes to my cart. Site customization is in my default box. So we're going to see if that fires off. Switch profile. What did I do for that? So that fires. So whatever I did in there would fire only if do this was true. So we'll set it to false. And now I shouldn't have do this in here. Yep, it's gone. So you can see that you can use conditionals. You can apply things to every machine. You can apply them on an appliance basis, on a key value pair basis, and whatnot. So, so there's a lot of things that you can do there. So we're still installing. We still got the RPM tools and then the post installation script. So what we'll do is I'll answer some more questions. Okay, so again, you don't have to wait for us to put out a pallet. I don't know if we are no longer in the pallet business, especially when it comes to open source. We have a few that are slated on our itinerary. We're doing this, Kubernetes, Docker, and we're deciding on what HPC pallets we wanted to do. And we're happy to turn those over to the community or take community help. We would love to have help. And in the future, probably at Stacki Fest, we'll be going over how to do pallet building of your own. So the question is, let's see this. The question from Arul is, Okay, so you have 10 bare metal servers on a network. You have root access and console access on these 10 boxes. You can, what? Okay, so you're going to need a Stacki front end, and you're going to have to reinstall that set of machines. If you have configuration on those machines that you are required to have, you would have to go and recreate that within Kickstart with a cart. We do not do brownfield. Let me be clear. This is greenfield. We do not do brownfield. We've got some brownfield type stuff in Stacki Pro, but we are not something that you put on top of something that exists already. Okay, Terry, I hear ya. Okay, Terry said, Cloudera palette, please. So we hear you. If you like it, if you want it, make sure you get some traffic going on our Slack group or Google group so that more than just so that the powers that be see that. The GitHub link for this presentation here, it should be here. Did that go? Okay. So I just sent that link, and it's on GitHub, stackiq.com/stackyhd, no, stackiq/stackyhdp-bridge. And the documentation is essentially what I've done here today. You've seen a little bit more because it actually picks up after you have installed a front end and stuff. Yeah, I think that you can get the HTTP script to point to an internal HTTP repository. I'd have to take a look at it. I don't know if I hard-coded that. I certainly can make it that way so that it can point to somewhere else. It is not currently compatible with Ubuntu. So Ubuntu is in our Stacki Pro. We can install Ubuntu machines and slush machines with the Stacki Pro product, but that's paid for subscription. And that's not under my bailiwick anymore, although I keep agitating to get Ubuntu into the Stacki open source. We'll see how that goes. That won't happen for at least another release, but I think I can make a safe argument that it'll work. You're welcome, Mark. When we add our hosts with a CSV file and specifically write their IPs and MACs, are their network interfaces configured as DHCP or static? Okay, so there's a static IP within the DHCP file. So let's take a look at what happens. Okay, as you can see, so let's take backend 3. So backend 3 has its MAC address, its fixed address, and its file name. Every time it makes a request for the DHCP, and the boot flag says whether you're going to be a local, you're going to install from whether you're going to boot from your local disk or from your or do an installation. It's always a DHCP request. It's always answered for that MAC address by this IP for this DHCP server. And it won't get any other interface any other IP address unless you specifically request that. So if you take a look at the interface host names, what you see here, actually, we loaded all the privates, but it discovered a secondary interface and populated the MAC address. You can now assign their own IP addresses and put them into and assign them a network as well if you want. So always DHCP, but they get this whatever static IP you assign them, and they won't get anything else. Stacki Fest is in April. Yeah, April. I just had the dates the other day, so I'll put that in there as soon as I know. Jay Coleman, did you get the link? I put it in the comments. If you didn't, we'll post it to the meetup, and we'll post it to everybody who is on this email. So we'll do two things. We'll do the GitHub repository, we'll do Stack, and we'll do Stacki Fest as well. No, when the machine is provisioned, I'm sorry, I wasn't clear. When the machine is provisioned, it is not a DHCP request, DHCP if config. When one comes up here, we'll go ahead and take a look at it. It is an actual, the if config file doesn't say it doesn't say DHCP in it. It says static. Okay, are there any other questions while we're still waiting for some of these to come up? We got them going. We should be there soon. The backend 0 is going to take a little more time because it gets a little more software. And here, I'll show you what I mean as soon as one of those comes up. No, that's not one. Clear that for you. If I could spell, it's because people are watching me. Okay, so you'll see to answer Sohei's question. I'm sorry if I butchered all your names. The hardware address, the IP address, and the boot protocol is static, so it's not set to DHCP. Okay, so we've got some machines up. They're not quite, they're done, but we're still waiting for backend 00, which is our Embari server. So we might have to give that about 2 more minutes. And let's open up a we'll open up an interface on here. As soon as it's up. So we've installed a bunch of machines. They're all prepped for Hadoop. Let's take a look, make sure they are. The stack run host command will run a command, an SSH command in parallel. You have all of those. All these machines do have passwordless SSH from the front end. Oh, I'm on the wrong machine. If you don't put any appliance or regex or hostname, it will do all of them. So we got a bunch of machines up, and we're going to do df-h. And we should have a Hadoop 01 on all of them. We do. Okay, so that's what we wanted. All right, so backend 00 is up. So let's go see if we can get into the what's its IP address? Oh, we're waiting on Embari to start. So it's possible to run things at the end of the at the end of the installation, and during the first boot. So typically that's what happens when you're doing installations of particular applications. There's lots of moving parts. Sometimes there's an order you have to do that. So if an IP of from Sohei also, if an IP of a Mac has to be changed in the future, you change it in the database. Let's go take a look. So you can change it in the database, stacks at host interface Mac for a particular machine. And then you can do a stack stack host sync. You can do a stack sync host network on the machines and do a restart, and that MAC address will be put into the correct configuration. If you want to assign another IP to a machine without provisioning, it's the same thing. Change it in the database, whether you do that in a spreadsheet and push it back in, or whether you do it on the command line and then sync the network configuration for that particular machine, that all just works. So you should be able to change all that information. All right, so let's see. Did we get this up correctly? Looks like it. Okay, when you sign into Embari, the default password and username is admin. I highly suggest that you change that, but that's up to you. So now at this point, there are a lot of people who either have, after they've installed their front-end machines, they might have Ansible or Puppet runs that set all this stuff up and they don't have to do this. It may also be that you have to set up Bari, and then you hand it off to a team and they're going to do the rest of this. Or if you're the one who's deploying it or developing it or doing whatever on your system, get up the Embari appliance, go to the web install, and launch the install wizard. We don't have a lot of time left, but we'll get as far as we can on this. We're going to give it a name. We're going to select the version. These are our versions. Now the base URL, these things you already have. They are in the yum.repository Stacki repo file. So HTTP bridge, HTTP utils. So we're going to cut this base URL. And we'll cut and paste this base URL. And somebody's going to say, oh, that's so 1990s. And I'm going to say it's possible. This is the sort of thing that when you're looking to automate further, this is the sort of thing that you go ahead and you put in your configuration to do that. We've done that in the past so that we know that sort of thing works. But at this point, it's not clear to me what the response from the community will be to do every single to go that far. So we're going to do backend 0, 1 through 4 as our list of hosts. We need to provide the private SSH key, and we're going to do this. It's in /root, and we're going to copy that and paste that in. This is so that Embari can get the same sort of access that you would have on the front end. A long time ago, we decided that what we really needed to do was we needed to take the management server outside of any application stack that was going to be deployed, and we did not want to have the front end be a single point of failure. We wanted to be able to disappear if it needed to or accidentally did, and not affect the running of your cluster. And so almost all services and management of a particular application go to another machine. Oh, wow, we actually succeeded on there. So this takes some time, and it'll start to bring up the applications that we want to be installed. With Hadoop, there's a very large list, so you really have to have an idea of what your users need and what you want. If you're going to put everything on there, you should know what the sort of things that conflict. So see, I got some warnings here, and I can't even begin to tell you the problems I would have fixing these checks on this particular set of machines, because they're under memory, they're underpowered, and they don't have enough disk. So we're going to see failures during this installation on this set of machines because it's insufficient. So this is a lot of stuff. And some of these things you should not be installing if you don't know, aren't clear on what they do and what you're going to use them for. So if you've got HBase on and you're also using MapReduce, you should take a real good look at the trade-offs that you're going to have to make to put both of them on there. So it gives you a bunch of default stuff. I just usually choose the defaults because I actually don't have to run Hadoop in what do you call it, in production. I would very much go through these and take a look and see and evaluate what I needed to have done. So we got a bunch of data nodes, supervisors. See, this is an awful lot of things. Actually, I only have 2 clients here. Not even sure what that means. 2. How does the other 2 not even get included there? So it's going to start to customize them and install them. It'll tell me warnings. So like Accumulo, Embari Metrics, Smart Sense, most of this is password type stuff that you have to put in. I'm not going to do that here at this time. Well, I guess I could. Everything's going to be admin. And just in case you're wondering, all this is going to go away as soon as we're done. So knowing that all my passwords are admin are not going to help anyone. So Cloudera actually gives you an awful lot of help in terms of what they think are the best parameters for what they've detected, and you should pay attention to them. And the fact that you have an Embari and Hadoop infrastructure that is outside of any real provisioning tool, so it's not on the interface. You could take Stacki out of here from here and just continue running your cluster. And what that means is that you have an Embari interface that they can use to help you troubleshoot if you choose to engage their support help. So we're going to deploy, and this may or may not actually work. We'll see. It's going to take a while. There's a lot of stuff to do there. So at this point, if people want to hang out, I'll leave this open. If anybody has any more questions, I'm happy to take them. But beyond that, this is as far as the demo goes. I hope you enjoyed it. I hope that it serves you some use. If you're using Hortonworks, let us know. If you need to see something else, something more, let us know either in Slack or on the Google groups. We're a pretty open community, and there's lots of people there to help, and we're more than happy to do so.